I'm Nick Muskowski, and this is collision theory. Collision theory was theorized by German chemist Max Trotz in 1916 and British chemist William Lewis in 1918. They both developed the same theory completely independently. For the longest time, chemists knew that increasing the temperature of a reaction or stirring a reaction caused the reaction to speed up, but they never knew why. Collision theory explains this. Collision theory explains reaction rates and what it takes for a reaction to occur. So, collision theory states that three conditions must be met for a reaction to occur. First, molecules must collide. Second, molecules must have sufficient energy. And third, molecules must be oriented properly. For the first one, molecules must physically collide to react. So, a chemical reaction won't happen if you keep both chemicals in separate beakers. Pretty straightforward. Secondly, molecules must contain enough energy to break the intramolecular forces, that means the forces between atoms within the molecules, of the reactants. Energy is shown in the temperature of a reaction and how quickly the particles move. So more energy means higher temperature and faster particles. So imagine you're backing out of a parking spot and you're going really slowly, but then you hit the car behind you. If you're going slow enough, you won't even dent the car behind you. This is analogous to the molecules not having enough energy for a reaction to occur. Lastly, molecules must have proper orientation. So, for an example, you can have nitric oxide combining with ozone to form nitrogen dioxide and oxygen gas. In the first one, the oxygen side of the nitric oxide hit the ozone, so no reaction occurred. In the second one, the nitrogen side hit the ozone, but it hit the center oxygen atom in the ozone, so it wasn't able to break an oxygen atom off. In the third one, the nitrogen side of the nitric oxide hit one of the side oxygen atoms in the ozone, so it was able to break off and form a bond with the nitrogen and form nitrogen dioxide and oxygen gas. So enzymes help with this in biological systems. Enzymes take two separate particles and they orient them properly to cause reactions to occur much faster. So here's a molecular view. You can see that there are a bunch of different collisions that happen, but not all of them result in a reaction. Only when the blue circle and the red square are facing each other with the black lines does a reaction occur. So this brings us back to our original question. Why does stirring or heating up a reaction increase the rate of the reaction? This is because as you stir a beaker, you increase the speed of the molecules, which results in more collisions, which results in more successful collisions that create reactions. And secondly, if you heat up a reaction, the molecules move faster, which means they have more energy, which makes it more likely that the molecules have enough energy to break the intramolecular forces, and they're moving faster, so there are more collisions. Thank you for listening.